All right, boys and girls, welcome to section 8.4. Today we're talking about wave interference. So this is another special property of waves that makes them different than physical objects. What interference is when two objects, think of like a physical object, two objects are in the same position at the same time. Okay, so for two physical objects, this is technically impossible. So let's say that I had, for example, a crate sliding to the left, sliding to the right, and another crate sliding to the left. Eventually, those two crates are going to meet at a location right in the middle. So what happens when two physical objects meet at the same point at the same time, that obviously they collide and they can reflect off of each other, they can bounce back, they can hit and stick, different things like that. That's when we talk about momentum and collisions. What makes waves interesting is that waves are not a physical object. Waves are instead just energy that's moving through a medium caused by a disturbance. So interference is what occurs when two waves meet in the same medium at the same location. So very similar to those two crates meeting at that same spot, same location. So what happens when two waves do it. So you'll see, for example, and this is not showing you actually what's going to happen. We'll look at that in a second. But let's say that I have here a crest moving to the right and a trough moving to the left. So interference is going to be what happens when those two waves meet, and they're going to meet some point in the middle. Okay. And something is going to occur when they meet, and we'll look at that. But then what happens, what makes waves unique, is that just like two ships in the nighttime, they're just simply going to pass through each other and continue to move on. So after interference, essentially what happens is that red wave that's moving to the right continues to move to the right, and that the blue wave moving to the left continues to move to the left. So in interference, there is, and this is what's interesting, there is no reflection that's taken place. So in this case, reflection does not occur. Reflection only occurs in our last section when we looked at a wave encountering a change in medium. So if we have two waves interacting within the same medium, they will not reflect, but instead they will interfere. And that's what we're going to focus on in this section. So there are two types of interference. First one's what's called constructive interference. So constructive interference is when we have two waves of the same phase, that rhymes, that are going to meet together. So, for example, if I have a crest meeting a crest, or if I have a trough meeting a trough, constructive interference is going to be what happens anytime we have the same phase. So the way we think about this is, here, if I have two crests, think of that as having a positive amplitude, and here a positive amplitude. And same thing for two troughs. Here I have a negative amplitude, and here I have a negative amplitude. So anytime our amplitudes are going to be of the same sign, whether positive or negative, that's constructive interference. All right, baby, so to show you constructive interference, again, it's when we have two of the same phase on the same medium. So here I have that wave generator that we were using. I created a crest that bounced off a loose end, so it was reflected back as a crest. And then I created a second crest that's moving through this medium. So they're going to be moving towards each other. Just to show you, notice they're both moving towards each other. So interference occurs when the two waves interact. So the key thing here is that they are not going to interact in such a way that they're going to reflect off each other or bounce off each other like two objects, but instead, interference means they're going to move through each other. So I want to show you this in slow motion. I kind of get one shot at this. I might have to restart it, but slow motion, I want you to watch what happens as they move through. So they're not bouncing back, but in the point when they meet, whoa, notice we had a larger wave that was formed, and now the two waves are just moving past. Okay, so I'm going to restart that. I'm going to create my first wave just to show you again. So I'll create a pulse. Whoops, let's go normal motion. Okay, it's going to hit that free end. I'm going to create a second pulse. So I want you to notice how they're moving towards each other. Boom. Notice right in the middle when they met, that was constructive interference. And then the key thing is when they continue to pass through and move along. Again, that is called constructive interference. Destructive interference occurs when we have two waves that are opposite phase that are going to interfere with each other. So here I have a crest and a trough meeting. A crest, again, think of that as having a positive amplitude, and a trough is anywhere where we have a negative amplitude. So when those meet, they are going to form what's called destructive interference. Okay, so think of constructive. Notice that the waves added together, they created a larger wave. Here, destructive interference means that they're going to destroy each other. All right, to demonstrate destructive interference, here I have two phases. I have the crest on the left side and the trough on the right side. They're going to be moving towards each other in this medium, and I want you to observe what happens when we have two waves that are undergoing destructive interference. Again, the neat thing about waves is that when they meet at that common point in the medium, they are not going to reflect off each other, but instead they're going to move through each other. So I want you to watch what happens when they move through each other. We're going to go here in normal motion. Let's take a look. Okay. Now they are going to bounce back in reverse phase again, so we'll go here in slow motion so we can kind of see what happens. So now they're going to meet. Whoa. Okay. Now that's kind of tricky. So we'll go normal motion here, and I'm going to take it frame by frame in this case. Okay, so now we're at the point where they're close to meeting. So here, notice the waves are getting closer towards each other, and then they're meeting now at that common point. I want you to watch what happens. Whoa. Notice here that the waves, and that kind of past that point, but notice how that medium is almost perfectly straight. Okay, so in that case, destructive interference, the two waves are going to destroy each other, and then afterwards, they just pass on through. So kind of watch it in total. The waves go towards, destruct, and they keep on moving. They are not bouncing, they're not reflecting back, but they're just moving through each other, and at that point in the middle is where you have that destructive interference. Okay, so constructive interference is when the two waves of the same phase meet, and destructive interference is when you have two waves of opposite phase are meeting. So what we're going to look at in this example is all we're going to point out is which of these positions, A through E, which of those represent constructive interference and destructive interference. So kind of like I showed, it's all about amplitude. In order to understand the idea of phase, crest or trough, we have to look at the amplitude. So understand real quick, I'll just write this on the bottom, that anytime we have a crest, think of that as a positive amplitude. Anytime that we have a trough, we're going to look at that as a negative amplitude. So constructive interference will occur when we have either a positive amplitude and a positive amplitude meeting, so they're the same, or it could be two negative amplitudes that are meeting. Destructive interference occurs when we have a positive amplitude meeting with a negative amplitude. So I'm just going to circle these. We're going to look at constructive interference versus destructive interference. So looking at position A would represent at the location right here for my two waves. So notice that both of those waves, the red and the blue, kind of overlapped on each other. Notice how they're both positive amplitudes. So here I have a positive amplitude for the red, positive amplitude for the blue. So that means for A, that would be constructive interference. I'll circle that in red for constructive. For B, notice I have the red is a positive amplitude and the blue is a positive amplitude. So that one would also be constructive. Position C, we have positive amplitude. So C is constructive. Oh my Lord, have mercy. All right, sassy one here. Notice how D, we have a negative amplitude for my red wave. We have a negative amplitude for the blue wave. So don't get confused. You hear the word destructive and you think, oh, destructive's negative, bro. Well, no, man. Anytime they're the same phase, whether positive or negative, that's going to create constructive interference. So technically D, because they're the same phase, they're both negative, they're both troughs, that would be constructive. It is in position E where I have a negative amplitude for my red wave and a positive amplitude for my blue wave. That is where we would see destructive interference. Okay, so constructive and destructive is all about the phase and what our amplitude is. So again, what makes waves unique is that when they interfere with each other, they are not reflecting, that they are passing through each other. But the point at which they pass through, depending on the wave's phase, whether they're a crest or a trough, is going to dictate whether we have constructive or destructive interference. And what we have seen is that for constructive interference, they're going to form a larger amplitude wave at that point of interference. For destructive interference, it's the opposite. They're going to form a smaller wave of an amplitude that's related to the two. So what they do is they follow what's called the superposition principle, that the resulting amplitude of the waves when they interfere is simply equal to the sum of the amplitudes of each wave. So again, this is called the superposition principle. They are going to superimpose on each other. So what it means is this, is notice I have my first case, this is constructive interference where I have the red and the blue. If we just think numerically here that the red wave has an amplitude of +1, the blue wave has an amplitude of +1. So that means when they interfere, if I add 1 plus 1 together, that means they're going to have an amplitude of +2. And you'll see that with that green wave, that their amplitudes add together and they form a larger wave. Same thing is true with troughs. Here I have an amplitude of -1 and -1. So when I add those two things together, they don't end up canceling each other out, but instead you get -2. And you'll notice that again by the green wave. So constructive interference, they simply add together and form a larger wave. For destructive interference, again, we have +1 and you have here -2. So if I were to add those two things together, +1 plus -2 would result in an overall amplitude of -1. And you'll see that here by the green wave that's shown. That's destructive interference. Now notice with destructive interference, in this case, they didn't completely destroy each other, okay, to completely cancel each other out, but instead they form a smaller wave. All right, so this is what's called the superposition principle, where all it is looking at the sums of their amplitudes to form that resulting wave. So what we're going to do here is we're going to look at this case. We have all these different points. We have two waves kind of superimposed on each other. And what we're going to do is draw the resulting wave. So the resulting wave is just simply equal to the sum of their amplitudes at those points. So for example, in this first point, notice that both my amplitudes are at 0. So you can think of this as a red and blue. We have 0 plus 0. All right, so what is that going to give me? That's going to give me 0. So my green wave would be there. The next one I have the red is at 1.5. The blue is at 3. So 1.5 plus 3 would be 4.5. The next one I have 2 and 4, which would give me 6. Again, I would have 1.5, then 0. All right, points aren't perfect here, but the next one, again, I'm going to have that 1.5 and 2. So we can again say about 3, and we can say about 4.5, then the 6, then the 4.5 again, and then back to 0. And this pattern is going to repeat itself. It's going to go to 4.5, then 6, then 4.5, 0. 4.5, then 6, then 4.5, then 0, and then 4.5, then 6, 4.5, and then 0. So if I were to draw this resulting wave, it would go up and then down. Again, those crests and troughs. Sorry if it's falling off. There we go. Boom, bada, boom. Not the prettiest thing in the world there. But that green wave would represent the two waves superimposed on each other. All it is simply adding the amplitudes together based on their crest or trough, based on their individual amplitudes. Now, this is a case that I've shown here of constructive interference, because notice I got a larger wave. If the amplitudes were in opposite phase, then we would have destructive interference. So in this lesson, we talked about the idea of interference, whether it's constructive or destructive. They follow that superposition principle where simply the amplitudes add together to form that larger or smaller resulting wave. Again, like always, any questions, jot those things down. Good luck on your concept builder. We'll see you next time. Peace out.